equal mc square.
I mean, you've been teaching for quite a while also, right?
Yes.
Apart from being university. Is there anything you look for in high school students as well? Like, for example, you look at a student and you say, okay, that student has the initiative, or he or she is a great student.
Okay. Knowledge-wise, whether the student is super smart or not, we cannot tell it immediately.
Right.
But at least I can see whether the student is confident or not. You know, we can see the confidence in their eyes, the determinations.
Right.
That's very important.
Okay.
Okay. I mean, confidence is not like it's like a stay low, but they know what they want, what they truly want, where they're going to go, something like that.
Like ambition.
It's like ambition and determination. It's more like calmness in their eyes, and when they talk to you, they know their main theme. They know what
The goal.
what the goal.
The goal
Yes.
is.
What's the next target they need to meet? Yes.
So just as a follow-up, you've taught for so many years. Has there been, you don't have to mention the student's name, but has there been a particular student that you were really impressed by? Or that student did something that...
Definitely your seniors in MPS last batch, they are amazing.
Okay.
Okay, some of them were given super challenging research topics. They embraced it instead of hiding from it. Okay? And in the whole process, they overcome so many obstacles to better their procedures, methodologies, until they figure out the correct way to do their research.
Right.
That happened to one of your Chem IA seniors last year.
Okay.
And his Chem IA scored 22 out of 24 in the end. He was the top scorer from the last batch. Chemistry Chem. Okay. He's not working in an easy topic, a very challenging topic. Okay?
Right. And did he come up with it himself? Or
That topic, he selected the topic himself.
also he knew it would be difficult.
He knew it was difficult.
Okay.
Yes. The moment he found any literature review, he knew it was going to be difficult. Because the literature review was so confusing.
Right.
They only give you the chemicals and equipment to use, but how to test it out? It's not mentioned that clearly. At least it's not like step 1 you do, step 2 you do. Not like that. Take some time to figure it out. And it must be figured out in the lab, not on paper. Okay, that literature review, 2 or 3 of them. You can keep reading them for 1 year of time. If you don't do them in the lab, we will never understand what's really happening.
Practical.
Yes.
Yeah.
Yes. That's why I keep saying that IA or E early on is a great benefit to the students. Yes.
Right. So also, like, in your personal opinion, do you know concepts that are taught in IGCSE or the lower grades? Do you think they prepare students well for IB, or are they too simplistic and can cause confusion and when they enter IB? Because, like, for me personally, in IGCSE we learned the atomic model, right? It was 2D and it was just very simplistic. And when I came to IB, then we learned about the electron cloud, and it was actually a 3D model with the board thing. So I personally was a bit confused. I got it eventually, but. So do you think it's a bit too simplistic in the low grades, or what do you think?
Okay, good question. This is a good but dangerous question. If I say I would say it's not good, then what can we do about it?
Right. No, but it's just your personal opinion. Yeah.
Never mind. The IGCSE Cambridge syllabus, it was set by whom? It's in the name, right? I think by Cambridge professors.
Right.
And I believe if no one else in the world knows how to teach chemistry better than Cambridge professors,
Right.
by those great educators, they design the modules.
Right.
They design what the concepts students need to learn for some good reasons.
Right.
Okay, for some good reasons. It's like this. The truth of this world sometimes it's hard to accept. Okay, it's simply as that. Okay, the truth of the world, like the orbitals world we are talking about. Even in the history when they were first discovered, it took a huge amount of effort and brainstorm between different chemists. They work all together, and great physicists as well. Okay,
Right.
they work all together to decipher it. So it's not a natural process for our human brain to process this knowledge, you know?
Right.
Talking about the quantum mechanics model of the particles, that's so against our daily observations of the world around us, right? The world around us is continuous.
Right.
For example, you can feel the wind continuously blowing on your face. You see the water flow, you can use them to wash your hands, it's continuous. But in the quantum model, what do they say about the law? They say the electron can only stay on some discrete energy levels, discrete position,
Right.
outside of the
So you think it's hard for us to comprehend that because that's in a natural world you don't see
So
that.
in lower grades understanding it.
Right. So it might be difficult for low grades.
It's quite difficult and challenging actually. Okay? So sometimes maybe but if we teach that so early,
Yeah.
I think maybe half of the class they refuse to learn after they even heard of the theory because it's so absurd.
Because even in IB it was difficult to fully grasp it at the very beginning. So I don't think low grades will.
Imagine doing that right in grade 8 or grade 9. What's going to happen? All the students are going to get confused. How come you see the wall is straight? I see a continuous wall everywhere.
Right.
Yeah. So it's, from educator's point of view, I think it's a good choice to screen those hard truths from the teenagers.
Right. So you think it's a good gradual, slowly you build up to that.
It's a gradual progress for you to learn and for you to adapt.
Right.
Yes. But you know, IB is where the final blow finally hits.
Yeah.
It's the
So, like talking about concepts, so what has been your favorite concept to teach in chemistry?
for IB chemistry.
Chemistry.
Okay, favorite concept. Yes.
Or I mean, sorry, it doesn't have to be IB. It could be that just whatever you've got. Yeah.
Oh, that's a good question. I mean, I like teaching IB chemistry. And okay, I think I may have many favorable concepts to teach. But one of the most favorable to me is I think Gibbs free energy.
Oh,
the one I just taught. Gibbs free energy. What's the physical meaning of it? Why we call it free energy? Okay, not other energies. Okay, so yeah.
So what's intriguing about it? Like, why do you like teaching it?
Yes. Yeah, good question. I think because it's like this. I think the most insightful part of Gibbs free energy is that in this world nothing is free for us. Okay? Even energy from the burning chemicals is not free for us. Part of this energy has to be wasted to compensate for the entropy increase of our universe. Otherwise our universe will not allow it to happen in the first place, right? So it's the idea that no pain, no gain. You know? You want something? Like even the wind blowing is not free for us, you know. When the wind is blowing to us, something else must pay the price. Well, what's something else? Temperature difference, right? Yeah, temperature difference, you know. So we cannot take everything for granted, even if it's natural energies around us. Right? So I mean, from my personal intuitions, it taught me how to be grateful for everything we have around us. Okay, so energies, matters, none of them is free. Okay.
So there's a lot of interesting topics and like concepts. So what do you think is like a good topic to do your chemistry at?
Oh yeah, good topic for chemistry. That's another very dangerous question. Out of so many topics in the syllabus, I think one of the most promising topic, of course, is kinetics, speed of reaction. That topic. I mean, there are countless number of reactions. That's doable. And also countless number of reactions for you to measure the rate of them. Right. Some reactions you can measure the rate of the reaction at different pH. And some of the reactions you can measure the rate of the reaction at different temperatures. But for some other reactions you can measure the rate of the reaction at different concentrations of the reactant.
Right.
Or maybe different concentrations of the spectator ions in the system. In IGCSE we have learned the idea of spectator ions. Ions that cancel off when you make ionic equations. But they do have some impact on the reaction system. Sometimes they will affect the rate of the reaction as well. Okay? So you see, it's a very flexible general topic. All you need to do is to find a chemical reaction that you're really interested in. Whether it's a reaction to do with medicines or chemical dyes or chemical fuels, oxidizing agent, reducing agent, anything. Okay? You just need to find a good chemical reaction that you really enjoy doing it. And then you measure the rate of it. And before you measure the rate, you need to figure out whether the independent variables do the change at first. Okay? And in our lab, we have more than one mature, trustworthy tools to measure accurately rate of your reaction. For example, visible light spectrophotometer is one of the tools you can use. We also have pressure sensor, So in case your reaction is generating gas, increasing the pressure of the system, you can measure the pressure. What if the reaction is making more electrolyte ions in the solution? You can use conductivity meter. Okay? So kinetics is like king of IA topics for chemistry.